My name's Ian Sheard. I'm the founding member, chief engineer for Seamagine Hydrospace. We've been building submersibles for about 30 years now. So I've always been interested in engineering, used to build radio controlled model aircraft, things hands-on. And when I left university, I did electronics and manufacturing, but I ended up doing work in the oil field sector. So basically, I was a field engineer exposed to all different forms of engineering, mechanical, hydraulic, pneumatic, worked in remote locations. And whilst there, I was actually out in West Africa. My partner, my current business partner, worked for the same company. And his brother had this balmy idea to make submersibles. And that was back in 1993, 1994, I think. And a few of us got together, thought, oh, it'd be cool to have a bit of a share in a submarine company. So we put some money in. And probably a few months later, I decided it was time to leave the oil industry. And I came by California, met Charlie, my partner's brother, and ended up staying to do the engineering. So at the time, it was just, okay, cool, let's design some submarines, start from a completely blank concept, don't have any preconceived ideas, because what we were doing back then was pretty unique anyway. And 30 years later, I'm still here in California.
Well, thank you for joining us. So we have some questions that were emailed to me by some of the students in Miss Hawkins' class in Henderson, Nevada. I just messaged me in the chat and we'll have you guys pepper those questions in. One of the kids wanted to know, can you tell us about one of your most memorable missions in your career?
Most memorable mission. I think actually it was probably early on. We had some tourist operations and we used to do it off the coast of Los Angeles here in Catalina Island. And that was quite exceptional, but the visibility wasn't always fantastic. We could get into the great kelp forest, which was quite spectacular. But we set up an operation in Grand Cayman. And I think probably the most memorable was my first trip out there. And we were only going shallow. And it was suddenly the visibility hit me that I could see what seemed to be for miles and miles. And just the colors and the fish and just basically the whole marine life, it was just mind blowing that visibility existed underwater. So although there's probably been more far-fetched and much deeper locations, I think that was the one that sticks in my mind as being just quite spectacular because I'd never seen that kind of visibility underwater before.
Very good. So I understand that Miss Hawkins' class, they had some questions. So Miss Hawkins, can you just make sure the kids are close to the microphone to where we can hear them?
Yes, you might not be able to see us all because the way I had the computer set up, but I will.
We just need to hear
You want
them.
us to put them in the chat, or do you want us just to go ahead and ask you?
Just have them come up to the microphone and ask, yeah?
Okay, I'm just going to set the computer down. I'm not sure what your view is, but then I'm going to have them come up and ask.
Yep.
So we were wondering how submarines are affected by the pressure of water as they go deeper into the ocean.
Okay, good question. I mean, most people think of a submarine as being basically, once it goes underwater, it displaces a certain volume of water. That's Archimedes' theorem. And when people start designing submarines, they think it's all about the weight and how all these components weigh together. But ultimately, you find out that typically the submarine displaces more than what it weighs, and you end up adding lead or you end up adding foam. But what happens as you go deeper is all submersibles will compress. So you think of it as it being, we call ours a 1-atmosphere submarine, so you don't get any real pressure change inside. But even in a big steel ball, it will compress and it will lose volume. So as you actually descend, the submarine does get heavier, and you have to be able to compensate for that weight as you go deeper and deeper. So you've probably seen some of the photographs of what we do, and basically you sit in the big goldfish bowl. So that window that you have, even though in some of the instances it can be 8 inches thick, as you go to maximum depth, that inside diameter will change by 1/2 inch, so 12 millimeters. So if you actually put a piece of string that's tight at surface, as you go down, that string will go loose because of the compression on the outside. And basically everything becomes a little bit smaller.
Okay, thank you.
Interesting. Interesting. Ms. Hawkins, do you guys have more questions?
I think we do have one more.
Yeah.
Do you have it, John?
Another question we have is, so how do you keep the insides of your submarines from freezing with the cold ocean temperatures?
Another good question. In our earlier submarines, they used to be all acrylic. So that's the window that you can see. It's not actually glass, it's plastic, it's acrylic. And because it's so thick, it's actually is very well insulated. So the warmth of just the people inside and the equipment that's in the side, so we have computers and other things that generate heat, typically keeps the temperature inside about 15 degrees Fahrenheit more than the ambient temperature. So really, even if you're going down to something that's 35 degrees Fahrenheit, so you're close to freezing, it's still going to be around 50 degrees Fahrenheit, 10 degrees C inside the cabin. And that's kind of as cold as it gets. With the new designs, or if you've got a steel hull, then it becomes a much bigger issue because it can get very, very cold. And two things you can do, you can either put insulation and cladding and insulation on the walls, and we do a little bit of that, or in the extreme environments, then you also need some kind of very warm clothing, potentially a survival suit or something. Typically, what all submersibles will carry thermal blankets as well, in case missions last longer than anticipated. But that's typically they can get cold. Usually you don't really have heating because heating takes up a lot of power. And one thing that you're always looking for with submersibles, which are typically battery powered, is to how to conserve power. So put a big thick woolly jumper on as opposed to putting a heater on.
Great
Okay.
advice. Great advice. Pinecrest and Sparata, do you guys have any more questions?
I'm not, do you have one more question? About submersibles? No, it has to be about.
We can come
I
back.
think we're good.
Okay.
Or if we think of something major, we'll ask in the chat or go back to it.
Sure thing. So we had a question emailed from Spain, and one of the kids wanted to know, what is the most challenging aspect of designing a submarine for deep sea exploration?
I guess for deep seas, yeah. So there's two. The most challenging I see is really surface logistics. So underwater, there's certain physics you can see, you can predict. At surface, then you've got wave action, you've got get people in and out. How do you launch and recover? And that's typically for all submersibles. For deep submersibles, really what you've got to do then is how do you maximize the viewing area that you have? So with our submersibles, you sit in this big goldfish bowl, but really you can only, that design is really good for about 7,500 feet, 2,300 meters. You start going deeper than that, then you start looking through a small porthole. So everybody knows how big is that window, and with new technology and new testing, you've been able to get bigger windows that give you a better view. And then as you go down is what you have is you have penetrations that go through the hull. So on shallower submersibles, what you think about is you've got electrical penetrations just for controls, for motors, for lights, and you've got mechanical penetrations for your ballast air, for oxygen, things like that. Once you start going deeper and deeper, then you want to minimize those penetrations that you have through a hull because they're all the weak points. So for instance, with the batteries, you obviously need to bring the batteries out, but if you can minimize the control signals that you are sending out, or the number of penetrations to say run the motors and everything. So basically you have a remote control system, shall we say, with minimal connections between the main cabin and exterior, say electronics pods, to do all the controls as opposed to having penetrations through the main hull. So it gets to be a bit of a different design philosophy as you go deeper.
That stuff is so fascinating. We have a few more student questions and we'll let you go. So one of the kids wanted to know, what are some emerging trends in underwater technology that you kind of find exciting?
I think a lot of the thing is we've been doing manned underwater, so the manned submersible for a long time. ROVs kind of took over from the manned underwater world back in probably the 70s. Manned underwater started coming back a little bit, and AUV, so the autonomous underwater vehicle, is probably one of the biggest technologies that is out there. And that is basically like a mini submarine that you put down. It's a robot that can go and basically scan quite large areas of the ocean floor or topography and bring that data back. And every instrument has its own kind of niche, I guess. Manned underwater is probably a smaller niche than some of these others, but I think the AUVs has a big part in being able to collect data that so far we're missing, because we don't really know a lot about the underwater world, even on the shores, 200, 300 meters. So we're talking about 1,000 feet. People have never been in those locations. And the manned submersibles still have a role, especially with the recreational side. So if people are buying them for their own personal use, but we're making discoveries all around the world because we're diving to depths where people have not been before and observing different creatures, different corals that, just haven't had the means. But as I say, with the AUVs, is that there's a lot of different technology, even from just recording video and samples that is now being deployed, which I think will enhance the learning that we all have about basically the underwater world.
And what's the deepest you've ever gone?
The deepest I've gone is about 1,000 meters. So that's 3,300 feet. So, and then I think next February we'll be going down to 4,300 feet. So
it's deep.
Well, you go to 1,000 feet, 3,000 feet once you go down, and it's surprisingly comfortable. In the new submersibles, you're in a very comfortable chair. You have music if you want. It's quiet, good temperature. So,
That's good. So we have a lot of brave kids out there who want to follow in your footsteps. There was a question from one of our kids in France, and they wanted to know what skills or education would you recommend for students interested in finding a career in your field?
I guess my field's a little bit, you got the engineering side and you got the marine biology side. Engineering side is, as I say, when I look for people, obviously they've got some kind of engineering background, but I also look for people who have a hands-on experience, whether it's from hobbies they have or working on the cars, something like that. Because I think for engineering, it's kind of important that you can connect what you learned with the actual physical hands-on aspect of it. It gets a little bit different now. Before, machining was classic, that when you used to machine an item, you could do it on the lathe or a mill, and people would come up with designs which were impossible to make, but now you can 3D print them. So if you can imagine it today, you can pretty much, actually make it. But for me, it's that on an engineering side, it gets some practical ability, see what hobbies there are or what organizations there are that to give you some hands-on experience. The marine biology side, and that's a different thing. There's a lot of organizations we work with, and there's a lot of big organizations that are hiring. So there's National Geographic. We work with National Geographic Pristine Seas, Google Foundation. They all have these big marine resources now that, give the opportunity to actually do some hands-on work out in the field.
That's great advice. Great advice. So our last question, we asked this of all of our guests on the podcast. Is there any advice that you can give Ian Sheard from Seamagine? Any advice you could give to them as they go out in the world and figure out what they want to do, whether it has to do with marine biology, whether it has to do with engineering or something completely different? What advice would you give to these kids?
I think it's you just keep an open mind and you just, okay, what am I interested in? What do I do? I know when I was 16, 17, you're looking to choose the A levels at that point, and you didn't really know. And electronics was up and coming, and I liked radio control planes. So I thought I'll just do electronics. So I went to university, I did electronics and manufacturing. I realized that's not really what I wanted to do, but that engineering background allowed me to do something different. And then it was just keep an open mind. I ended up in the oil field. I never thought I'd be going in the oil field. And whilst I was there, then, I met my partner and ended up in California building submarines, and California and submarines was never on the horizon. So I think it's an open mind. You just keep doing, do your best at what you do. And you realize the choices that you make, you know, it all seems so important at your age, is this next set of exams, and they are to some extent, but they're all stepping stones to what comes next. And horizons will open, and it's just taking those opportunities as they arise. And, you know, they could lead you on whatever path that you can't even imagine at the moment.
Wonderful advice. We had one more question pop in. This is the last question I wanted to know from Pinecrest and Inspirada, Nevada. Have you ever had difficulties with pollution at those deep levels?
Not massive pollution, but we've been down at, you know, a couple of 1,000 feet, and you see Coke cans, you see tires. We're recently out in Papua New Guinea just doing training dives and setup dives out there, and you're off an island which really there's no forms of transport. It's basically basic huts, and the people who've been living like that for hundreds of years. And down there at a few hundred meters, you find still cans and a tire and things like that. So there is, it is everywhere. Obviously places like that, you see less of it. And I think what it is, it's probably where the ocean currents go. It will, in the end, it'll all be in one location, or not one location, but several, where it all ends up hanging. And I've not come across that, but it, you know, obviously along the seashores in many places, you see all the plastics and things that are washed up. So now there is a big push, and I see it a lot in the yachting industry, which is what is our side, and the research industry, is that, you know, plastic water bottles are a thing of the past, and everybody travels with their own separate water container and fills it up as they go. So I think as the awareness and people do that, then, you know, hopefully we'll have less trash in the ocean, both for the surface and what will end up in the depths.
Great. Thank you for touching on that. Before we let you go, I want to say thank you for taking the time on such short notice to connect with us. This was life-changing for many, many kids. So I'm asking everyone, can we all unmute before I end the meeting for all? Can we all collectively say thank you to Ian for taking time out of his day to come talk to us? Thank you so much.
Thank you.
Bye.
We appreciate it.
Thank you very much. Pleasure talking to you all.